The planets in our solar system are divided into two separate regions: the rocky worlds of the inner solar system and the gas giants of the outer solar system. Interestingly, there's a structure that separates the two regions of the solar system, located between the outermost rocky planet Mars and the innermost gas giant Jupiter. That structure is the asteroid belt. The asteroid belt is a torus-shaped region in the solar system. It contains a great many solid, irregularly shaped bodies of many sizes, but much smaller than planets, called asteroids or minor planets. This asteroid belt is also called the main asteroid belt or main belt, to distinguish it from other asteroid populations in the solar system, such as near-Earth asteroids and Trojan asteroids. So what do you think about how big the asteroid belt is? And what is the composition mass of the asteroid belt? How dangerous is traversing the asteroid belt? Before moving forward in the video, we have to know about how the asteroid belt was discovered. Johann Titius, an 18th century German astronomer, noted a mathematical pattern in the layout of the planets and used it to predict the existence of one between Mars and Jupiter. Astronomers scoured the heavens in search of this missing body. In 1800s, 25 astronomers from the group known as the Celestial Police, each searching 15 degrees of the zodiac for the missing planet. But the discovery of the first body in this region came from a non-member, Italian astronomer Giuseppe Piazzi. He named it Ceres. A second body, Pallas, was found a little over a year later. For some time, both of these objects were referred to as planets, but the discovery rate of these objects increased, and by the beginning of the 19th century, more than 100 had been found. Accordingly, in 1802, William Herschel suggested they be placed into a separate category, named asteroids, after the Greek asteroides, meaning star-like. The asteroid belt has an estimate size of 140 million miles, 225 million kilometers across. That's about 1.5 times larger than the distance between the Earth and Sun. The asteroid belt is located anywhere from 300 to 390 million miles, 480 to 628 million kilometers away from the Earth. The closest planet to the asteroid belt is Mars, which is located about 47 million miles, 75 million kilometers from the innermost region of the asteroid belt. Beyond the asteroid belt is Jupiter, which is located much further away from the asteroid belt than Mars is. On average, Jupiter is located 242 million miles, 375 million kilometers away from the asteroid belt. Objects in the belt are divided into 8 subgroups, named after the main asteroids in each group. These groups are the Hungarias, Floras, Phocaea, Coronis, Eos, Themis, Cybele, and Hildas. The high population of the asteroid belt makes for a very active environment, where collisions between asteroids occur frequently on astronomical timescales. Collisions between main belt bodies with a mean radius of 10 kilometers are expected to occur about once every 10 million years. A collision may fragment an asteroid into numerous smaller pieces, leading to the formation of a new asteroid family. Along with the asteroid bodies, the asteroid belt also contains bands of dust with particle radii of up to a few hundred micrometers. This fine material is produced, at least in part, from collisions between asteroids, and by the impact of micrometeorites upon the asteroids. Due to the Poynting-Robertson effect, the pressure of solar radiation causes this dust to slowly spiral inward toward the Sun. The combination of this fine asteroid dust, as well as ejected cometary material, produces the Zodiacal Light. This faint auroral glow can be viewed at night extending from the direction of the Sun along the plane of the ecliptic. Asteroid particles that produce the visible Zodiacal Light average about 40 micrometers in radius. The typical lifetimes of main belt zodiacal cloud particles are about 700,000 years. Most of the asteroids in the main belt are made of rock and stone, but a small portion of them contain iron and nickel metals. The remaining asteroids are made up of a mix of those, along with carbon-rich materials. Some of the more distant asteroids tend to contain more ices, although they aren't large enough to maintain an atmosphere, but there is evidence that some asteroids contain water. Asteroids are classified into several types, based on their chemical composition and their reflectivity or albedo. C-type asteroids make up more than 75% of known asteroids. The C stands for carbon, and the surfaces of these extremely dark asteroids are almost coal black. Carbonaceous chondrite meteorites on Earth have a similar composition, and are thought to be pieces smashed off the larger asteroids. While C-type asteroids dominate in the belt, according to the European Space Agency, they make up only about 40% of the asteroids closer to the Sun. This includes subgroups of B-type, F-type, and G-types. S-type asteroids are the second most common type, making up about 17% of known asteroids. They dominate the inner asteroid belt, becoming rarer further out. They are brighter and have metallic nickel-iron mixed with iron and magnesium silicates. The S stands for silicaceous. M-type asteroids, M for metallic, are the last major type. These asteroids are fairly bright, and most of them are composed of pure nickel-iron. They tend to be found in the middle region of the asteroid belt. The remaining rare types of asteroids are A-type, D-type, E-type, P-type, Q-type, and R-type. Despite the immense size of the asteroid belt, its mass is actually very small. Although the asteroid belt contains millions of asteroids, all of it adds up to only about 3% the mass of Earth's moon. If you were to combine every asteroid into a single object, it would be significantly smaller than the moon. In fact, over 60% of the total mass in the asteroid belt is contained within just 4 objects: Ceres, Vesta, Pallas, and Hygeia. Nearly 40% of the mass is contained within Ceres alone. And the only object in the asteroid belt large enough to be a dwarf planet is about 950 kilometers in diameter. Ceres is the only dwarf planet, located in the inner solar system, whereas Vesta, Pallas, and Hygeia have mean diameters less than 600 kilometers. The remaining bodies range down to the size of a dust particle. While sci-fi movies and films have popularized the idea that traveling through an asteroid belt is exceedingly dangerous, this is not actually the case. In fact, every spacecraft that has traveled beyond Mars has entered the asteroid belt with no issues. While works of sci-fi make it appear as though collisions with asteroids are a real danger, the actual distances between individual asteroids is so vast that a collision is exceedingly unlikely. In fact, if you were to stand on an asteroid within the asteroid belt, you would not be able to identify even the closest asteroids. Their distance would make them look no different from the distant stars. The first spacecraft to traverse the asteroid belt was Pioneer 10, which entered the region on 16 July 1972. At the time, there was some concern that the debris in the belt would pose a hazard to the spacecraft, but it has since been safely traversed by 12 spacecraft without incident and will continue to happen in the future. In the future, if our technology gets even better, we humans will also get a chance to pass through the asteroid belt. If you enjoyed this informative video, please like it and share it with others. Also, please subscribe to my channel for more such content. Thank you for watching.